Magnetism and Electricity, Video 2, Investigation 1, The Force. Hey, it's Nick Kapoor from the Winship School again, continuing the video series for the FOSS Magnetism and Electricity unit. The focus of this video is going to be on Unit Investigation 1, The Force, which is broken into 4 parts, and according to the teacher's guide, should take you 4 or 5 teaching sessions of approximately 45 minutes each. I listed the Massachusetts state standards for the unit in video 1, so in the interest of time, I'm not going to go over them again, but these are the student learning outcomes for this investigation. Again, you can find these on the Science Department Weebly site. I do want to mention at the beginning here that if this is the first time you're teaching this unit, these videos are meant to supplement your review of the teacher's guide, not replace it. I'm going to try to give some tips on how to manage and implement the unit, but I won't go through each lesson step by step. For each investigation, if you're completely unfamiliar with the science content in the unit, you should read the beginning pages of the teacher's guide for each investigation. They do a great job of summarizing the lessons as well as providing background information for the teacher. So for example, for this investigation, you would be looking at pages 1 through 7 for the background information. Basically, in this lesson sequence, you're going to be teaching your students about the properties of magnets. In part 1, students are given the opportunity to investigate the properties of magnets, mainly that sometimes they attract each other and sometimes they repel each other. They also test which objects are attracted to magnets and which are not. If time allows, I like to give students the first day with magnets while they're just exploring what magnets can do. For most kids, this is an exciting thing, and I like to give them a little time to get the playing with magnets out of their system instead of trying to get them to immediately record observations in their notebook. This could even be done when you have an extra 10 to 15 minutes at the end of the day or at the end of another lesson, as long as you have time to have a wrap-up discussion where kids share their ideas and findings. When setting up for this unit, I do like to draw an N for north and an S for south directly onto the magnets, so that even at this early stage, it's being constantly visually reinforced that like poles repel and opposite poles attract. Once you're ready to let students investigate the magnetism test objects, it's important to have them predict which objects they think will stick to a magnet, attract, and which ones won't, by sorting the objects into these 2 prediction piles. Mostly, students will predict that all metal objects will stick to a magnet, and will have to discover that not all of them do. Actually seeing that this prediction does not come true is an important experience to try to combat this commonly held misconception. For the purpose of this unit, we teach students that if something sticks to a magnet, it has iron or steel in it. In order to support our ESL and SPED population, I use a picture chart, which you can find in the shared Google Drive folder that I mentioned in video 1. I also included the list on the science notebook page that I created to both help with spelling and for students to keep track of which objects they return to the bag after each lesson. So this is the list right here. It's important to have students check this list after each lesson to make sure you're not losing the test objects. In part 2, students are introduced to the concept of induced magnetism, which creates a temporary magnet, something like an iron nail that acts like a magnet when it's touching a permanent magnet. Many of the same supports and scaffolds can be used again for this lesson, so reading through the teacher's guide is useful to clarify this part of the investigation. One interesting thing that students may discover is that the permanent magnet does not actually have to be touching something to induce magnetism. The object just has to be in the permanent magnet's magnetic field. In part 3, students use a balance to test how much force it takes to break the force between 2 magnets. They find that the closer 2 magnets are to each other, the stronger the force between them will be. The farther apart they are, the weaker the force between them gets. 2 important things to note from this part of the investigation. First, I explicitly model the setup and method in which students will add the washers to their cup. Without modeling, some students may slam the washers into the cup, some may place them gently, and results will be varied. You might find this is a good opportunity for a class discussion about why results are varied, but each group needs to at least be consistent from trial to trial, or you risk having them learn the wrong science. Second, I like to break this part into 2 sessions. In the first session, students only need to conduct the investigation and organize their data. You can decide which students need to have a data table provided for them, which can have a class data table modeled for them to copy, and which may create their own method for organizing data. You might consider creating a couple different data tables to provide your ESL and SPED populations the support they need based on their level of need. The second day, I explicitly teach going from data table to graph. We have a class discussion about what the data means and how we know. Students can then write their own thoughts and conclusions on their worksheet or in their notebook. I've also developed an open response prompt for this part of the investigation and made that available in the Science Notebooks Google Drive folder also. Finally, in part four of this investigation, students complete this part of the unit by detecting the force of magnetism. You can follow the directions in the teacher's guide or also make this lesson more like 3 centers. One in which the students find the magnets in the mystery boxes using a compass, one in which the students observe and describe the magnetic field by using iron filings, and another center where students use a compass to determine which side of the magnet is north and which side is south. While this is not in the teacher's guide, it's a good place for a formative assessment to see if they know that opposite poles attract. I didn't mention this before, but throughout the teacher's guide, they suggest when the reading lessons can be completed. That's it for this part of the investigation 1, the force. In the next video, I'll continue on to investigation 2, making connections.